This video will deal with 11.5, problem 11.5 from Gapenski's Healthcare Finance 6th edition. Problem 11.5 is Minneapolis Health System has bonds outstanding that have 4 years remaining to maturity, a coupon interest rate of 9% paid annually, and a $1,000 par value. Okay, so what do we know? So we know that it has 4 years and it pays interest annually, so N is actually 4. The coupon rate is 9%, which means, and the par is 1,000. So therefore, the payment, the annual payment, is going to be 1,000 times 0.09 or 90. So we set up our little timeline. 1, 2, 3, 2, 3, 4. Yeah, I can count. And our payments are going to be 90, 90, 90, 90, and 1,090. Sorry, and 1,000 for 1,090. Total of 1,090. So we'll have 4 $90 payments and one $1,000 payment at the end, or 3 $90 payments and one $1,090 payment. However you look at it, doesn't matter. Okay, so part A says, what is the yield to maturity on the issue if the current market price is $8.29? So that's saying, well, the PV is $8.29. What is the yield to maturity, right, or interest rate? Implied interest rate. Well, easy enough to do. Clear our TVM from our last example. Okay, so we know N is 4. We don't know the interest rate. That's what we're trying to figure out. Our PV is 829. I'm going to make that negative. Our payment is 90. And our par is 1,000. So our future value is 1,000. So compute interest rate per year. And we get 14.98, 14.99%. Okay, part B says if the current market price is actually 1104. Okay, so now we're going to change that this assumption, right? And we're going to make the PV 1104. What is the yield to maturity? So everything else stays the same. N is 4, C is 9%, par is 1,000. Okay, let's do our intuition again. I forgot to do this earlier. So here we said C is 9, right? And we said that PV is 829, and that's less than our par, right? So our price is down, which means that our interest rate must be up. So we knew we could have imputed that our interest rate would be greater than our coupon rate. So we should have been, by intuition, we should have said, okay, the number we're looking for is something bigger than 9%. Well, now over here, what we know is par is less than the PV, right? Because 1,000 is less than 1104. So therefore, what must be true is the coupon rate must be greater than the interest rate. So now we're looking for an interest rate that is less than 9%. So what is that number going to be? All right, well, we know, excuse me, we know, clear our TVM, we know N is 4. We know that the payment is 90. We know that the future value is 1,000. And then we know that the PV is 1104 negative. Compute interest rate, and we get 5.998, so effectively 6%. And the last question for 11.5 is, would you be willing to buy one of these bonds for $829 if you required a 12% rate of return on the issue? Explain your answer. So would you be willing to get buy either of these bonds if you require a 12% rate of return? Well, a 12% rate of return for this, we could calculate what that implied PV is. So that, and then we'll know if we're getting a bargain or not. So what's the PV? If the interest rate is 12, the payment is still 90, the future value is still 1,000. And of course, n is still 4. So let's pull up our handy dandy calculator here, clear. So 12 is the interest rate, 4 is the n, 90 is the payment, 1,000 is the FV, compute PV, and we'd be willing to pay $908 for a bond that pays $90 per year, and it has a par value of 1,000 for 4 years. So we'd be willing to pay $908. So if we could pay $829 for it, then that would be quite a bargain. So we'd be happy with that, because the 829, as you remember, actually implies a almost 15% interest rate. So if we could pay $829, we'd be getting a almost 15% interest rate when all we actually require is 12%. So that's a good deal for us.